what we're going to do is if you're not presenting, if you could please turn your mics and cameras off so that we can highlight the presenters, that would be great. We have 5 teams going today. We'll start with V-Light. I already see them starting to get ready. Thank you so much. Then we'll have amuseum, chain reaction, exposé, and we'll end with blind spot. So you have 15 minutes. Keep track of time on your computers and 5 minutes Q&A. So with that said, V-Light, if you can turn your cameras and mics on, I will find you and get you spotlit so we can highlight you. Just a second. Let's see. That's all of you all. So whenever you're ready.
Thank you. But before the presentation, can you verify that you see the picture, see the hear the song?
Yes.
So let's start. Welcome to our show. In this project, we are dedicated to creating an edge-native multiplayer AR game. In the game, we are warriors of an alien solar system, fighting for energies to save the lives on your planet. This is our team. 4 programmers, 1 UI UX designer, spread over 4 international cities and 12-hour time zones. Here are our clients. Jensen Hammer, you all know, Bob and John, who are engineers from InterDigital.
With our clients, we got 2 missions from them. First, Bob and John from InterDigital would like us to show off edge computing, try to let the public know the potential and how important it can be. Second, Jessica was planning to publish several papers related to edge computing. In that case, we were asked to collect data which can be strong support to prove that edge computing is a good fit for a mobile AR game. With those goals, we defined our 4 metrics as following. First of course, we want to make our client happy. Second, we would like to explore new technology which none of us had any experience before. Next, we want to try different ways to design game. Usually, we find the appropriate technology to fit the design, but in this time, we have to design for the specific technology. Finally, because we have the responsibility to promote edge computing, we think it's also important to have several playtests to understand what others think of our project. Before we continue to our work, let's have a real quick recap. What is edge computing? Edge computing brings computation and data storage closer to the devices where it's being gathered, rather than relying on a central location that can be thousands of miles away. Moreover, in this way, you can store confidential information on your local site to better protect your data. It is done so that data, especially when you are trying to send some real-time data, it doesn't suffer from latency issues. Yeah, and another thing to mention is that the cooperation between EDC and our clients actually started from last semester. Last semester, Xroom created a multiplayer interactive XR game, which is Disco Arena. By utilizing the advantage of edge computing, players can enjoy fast synchronized interactions and high-quality visual effects without any powerful hardware in their handheld devices. We had carefully studied their project, talked to the team members, and found that Disco Arena is no doubt an interesting and creative game. However, the computational load may not have enough for us to show off the power of edge computing. So in order to make the computation more intense, we decided to make a game not only featuring the AR technique, but also featuring AI. Next, Leslie will talk about our approach.
To which, after brainstorm and discussion with professors, the AI feature we decided to add is human recognition. We would like to add armors on players' head and body to add more spice and computational load to the game. To do that, we tried Lens Studio, TensorFlow, PoseNet, and OpenPose. It turned out that OpenPose made our goal the best. OpenPose needs us to input a stream of images, and it gives us 2D coordinates of 18 key points of the body. However, it also means that OpenPose is not compatible with Discord Arena, which uses 3D coordinates to locate players. Since our main purpose is to try our best to show off the power of edge computing, we have to give up the idea of building our game upon Discord Arena. So here comes our B-Light. Instead of using 3D coordinates to reflect light into other players' faces, we use 2D coordinates to locate players, equip them with armors, and let them shoot each other. Before the half presentation, we tried 2D armors and 3D armors, but neither of them was good enough. So after the half presentation, we applied more visual effects, such as flowing light, heating effects, and small particles flowing around. Next, Eric will introduce you the most important part, edge computing.
Thank you, Leslie. As most of the audience, none of us has any experience with edge computing before, not to mention creating an edge-native AR game. Fortunately, Jessica connected us to Dr. Satya, who is a professor of computer science at CMU. He's also known as the father of edge computing. In week 3, we had a Zoom meeting with Dr. Satya and explained what we were doing. He was very interested in the project and sent Tom, a senior scientist in his lab, to collaborate with us. Dr. Satya's lab has developed an edge computing platform called Gabriel to support wearable cognitive assistance applications. In just a few days, we were able to set up the Gabriel system by working closely with Tom. We felt very lucky. However, we quickly realized that nearly all existing Gabriel projects were developed in either Android Studio or Python. On the other hand, we were planning to build the AR game in Unity, which meant that we had to create the connection between Unity and Gabriel by ourselves. The task turns out to be very challenging. In the following 2 weeks, we tried many different methods to solve the problem as listed on this slide, but none of them worked. It was really, really frustrating. We didn't give up. We decided to develop our own Unity client for the Gabriel system, which is a longer but a more controllable path. We consulted senior software engineers, purchased a Unity plugin called Best HTTP, and studied the source code of OpenArtist. The efforts were paid off eventually. On the Saturday afternoon of week 7, we finally made a breakthrough and managed to connect Gabriel's server and the Unity client. But there are more technical issues to resolve. In the following weeks, we fought with memory leakage, speed bottlenecks, connection instability, so on and so forth. The efforts will not only benefit this project, but also provide a foundation for future edge-based game development. So much for the technologies. Now let's turn to the game design.
Thanks, Eric. After implementing a single-player demo, we held our first playtest. We found that there's 2 designs to improve. Mia, how can we fix that?
Yes, so first we switched into an AR tutorial because based on playtest feedback, we found there's a gap between our previous 2D tutorial and the AR game world. For example, players know they need to collect bullet supply, but it was hard to find where's a bullet supply in the AR world. So we made the decision to switch into an AR tutorial that will guide the player to move their phone around to find the bullet supply. And only if player collected successfully, it will move to the next step. Second iteration is we removed knee armor and replace with helmet. Because in playtest, we found players tend to target at the belly and elbow instead of knee, because they don't like to move their phone up and down drastically. So we made the decision to use a hat, which lets players fix on the upper part. Next, Alan will introduce a unique server design.
Thanks, Mia. After we iterated our single-player experience, we started to implement our multiplayer system. We need a low latency and bandwidth saving system to avoid interference with the OpenPOS server. Based on these requirements, we designed and implemented this unique data structure and synchronization protocol. In our design, 2 client phones will send event signal to the server, like A and B. And the server will broadcast the same information to both clients, and the client will pass the info locally and show related feedback, like I got hit. We did not choose the peer-to-peer style network server design because our program already requires a server to run and usually takes more time for users to configure a peer-to-peer network.
After that, we conducted our second playtest, which was more formal at ETC building. We have 9 playtesters joining us there. The good news is that everyone loved our game and they gave us valuable feedback.
Yes, but almost everyone had the same feeling that there's too many elements on the screen. We have a really intense shooting game. Players are busy shooting each other. They have no time to look at 3 health bars or some animation in the game. So we made 2 iterations. First one is simplify UI, but just use 1 health bar. That is more clear and give player more space to target every enemy. Second iteration is replaced with more obvious feedback. For example, in previous design, when a player got hit, there's an animation in the health bar, but no one noticed that in the playtest. So we replace it with a pop-up that is more direct and more obvious. That's what we learned in 2 playtests, and next I will talk more about soft opening.
Thanks, Mia. We got a lot of feedbacks from our faculty members on the soft opening. Based on the feedback, we have improved our game by adding more features. We don't want players to move too fast due to latency and open pose server limitations, so that we planned on creating a dynamic crosshair system. If player is moving, his or her shot will be less accurate. Here is what this system looks like in our game. We also optimized the webcam resolution for our game to reduce the game's latency. Our game will use higher webcam resolution for the display on Android phones and use low resolution for the post-estimation on the server. The latency is reduced because low-res pictures have smaller file size and can be transferred through network quicker. Smaller pictures can also be processed by OpenPose faster.
Well, here we would like to show you the significant difference between cloud versus edge. Actually, we didn't really deploy our project to clouds such as AWS or GCP. Instead, we set up our server here in Pittsburgh. And our team member who is based in Canada, which is very far away here, to test the performance. And it is what it looks like. The upper left corner is what happened in real world. As you can see, there's a noticeable lag between real world and in the game. It is totally not acceptable while we're playing a shooting game. And for the edge version, the server and the handheld client is physically in the same place. As you can see, there is still a little lag, but through our playtest, we are sure that the game still goes well with this tiny lag. So here's our deliverables. For our game, we're not going to demo the whole game, but just a glance about how it looks like.
We are creating V-Light, a 2-player AR shooting game. In the game world, 2 players are space warriors, and they are competing each other. Players wear armors. Those armor are shootable area. Players need to shoot enemies' armor to win the game. There are 2 buttons. Click button to get bullet supply. Shoot button to fire at your enemy. We set a 3-minute limitation. If won, congratulations, player can go and get the reward.
Also, we collected a lot of data during this project and helped our clients successfully submit a paper. And also from the suggestion of our clients, we are going to open source. We cleaned up our code and also carefully documented our project.
Finally, we would like to thank our advisors, clients, collaborators. Without their support, we won't be able to go this far. We believe that all project objectives have been achieved. Our clients are satisfied with the outcome of the project. We were exposed to cutting-edge technologies during the exploration, and we did 6 playtests and iterations to improve user experience. It was a great, fruitful learning experience. To conclude, in this project, we created an edge-native AR game by integrating AR with OpenPose and Gabriel. We performed the data analysis and contributed to a research paper titled V-Light, Leveraging Edge Computing for Mobile Augmented Reality. We decided to open source the project to the community to benefit future edge-based game development. With that, we are open for questions.
All right, congratulations team on your final presentation. Good job. So if you just want to ask questions, put them in the chat and Dave can help moderate. And I see Mo's already up there. So Mo, go for it.
Yeah, I liked, it was a nice demonstration of the latency of edge computing versus non-edge computing. Do you have numbers associated with that latency though, beyond the visual demonstration?
Actually, we have some data, but let me show you something here. This is the data we have. Where is it? So for the latency, we have this is total round trip, and we know how much is spent on the server, how much spent on the client part, and how much on the traffic, the network traffic. But for the comparison with the cloud, and the work is done by our clients who's running their own software called Advantage, and those results were summarized in a paper, and we didn't go that far because of the time limitation. But we do have the data, but we don't have the time to show in this presentation. Yeah, but later, if you are interested in more details, we can talk about that later. Thank you. Great question.
Mike, you had a question?
Yeah, it seemed even in that video you showed, the comparison, and also in some of the ending video, that your human player was moving a bit slower than you would in a dodge game where you can move real quickly. So I am guessing that if you move real quickly, the human player would see some lag in the current setup. Can you explain if that's true? Is it because of network delay or open pose, or why can't a human really go crazy with their dodge movements? Because it seems like there will be lag.
Wish, do you want to explain?
I think you want to show our teaser at the very beginning.
Okay, but that's not the final version. That's this one.
Yeah, because I think in this video you can see like we're moving more quicker than the demo, and as you can see through the cell phone, it is not really so lag. So I think it is totally acceptable.
But let me add one more thing. It also depends on the hardware. This happened to us. When you test it in a better router and better networking environment, the performance is much better. But if you are actually, that happened in the EPC building. The day before they have a very good performance, but afterward, when too many people connect to the network, the performance is not so good. But you're right that the current latency is not so ideal for very quick movement, but I think it's acceptable for a reasonable shooting. And also we, as Alan explained, that we add a mechanism to demotivate people to move. If they move fast, then they cannot aim accurately. Yeah, that's the efforts we made.
Bob, do you have a question?
Yeah, so I know that you decided to go with edge computing and you decided to build your own link between the Gabriel platform and Unity. I was wondering if you looked at if there was a way to make an AR game with Android Studio or completely Python, and what did you find there? Or maybe there aren't any options. I'm just wondering.
Yes, it's actually in that GitHub, in the Professor Satier's lab's GitHub, there are about 80 repo. You can find a similar project, but either in most of them in Android Studio, also in Python. There are a lot of open. All of them are open source. So if you want to develop it in Android Studio, it's very convenient to start from there. Here. You can go to their GitHub. Actually, we downloaded several of them and learned a lot from their even it's Android Studio, we learned a lot and we try to adapt it to Unity.
Oh, okay. All right. Thank you.
All right, that's time. Congratulations, team. Good job on your finals. And if you all can turn your mics and cameras off, we'll get you off spotlight. Get you out of the spotlight. And if a museum is ready, I will get you in the spotlight. I'm missing wizard. All right, that's all of you whenever you're ready.
Okay, the gang's all here. All right, good morning, everybody. We are a museum, and this semester we developed an augmented reality interactive installation inspired by the work of Rube Goldberg using the Arena mixed reality platform for Anne Follenkamp and the Children's Museum of Pittsburgh for their museum lab specifically, targeting an older audience of 9 to 15. So the museum already has several of their own fully physical Rube Goldberg machines installed, but they came to us wanting to include AR in a new machine, as there are many tropes in the designs of Rube Goldberg's cartoons that just aren't really physically possible to replicate in a museum itself. So we selected Arena as our AR platform for its robust networking capabilities, as this is a public installation, so multiple guests might be joining and viewing this at the same time. And next week, we'll be delivering all of the physical elements of our project, the keys to the scene in Arena, and a documentation packet outlining setup and maintenance information. So Rube Goldberg's cartoons bring a richness of inspiration for an intertwining of narrative, comedy, and physics. And using this inspiration, we set about creating a machine that teaches guests a simple way to send a letter in the snail mail. And we can jump into showing the machine in first person and their experience going through it. They will use either their own personal device or a device in the museum space, scan a QR code on the instruction sheet to open the web page in Arena. From there, they'll scan an April tag on the table, which will place all of the objects in virtual space. And if the machine is ready to go, they'll have a sign appear that says that it is ready to send the letter. And they will hold down the red button on the typewriter, which will start the machine. And if they look up at the machine, they'll see a bird sleeping on top of a bird cage. Holding this red button releases the weight as well as the letter, sending it back into the envelope. That weight both kicks on the fan in the space and wakes up the bird. The bird will grab an umbrella and using the air from the fan down below, it will glide across to the next bookshelf where it will peck at the statue of a bird supporting the books and knocking one down onto the fire bellows, inflating a balloon, and watering the plant, causing multiple flowers to bloom and several bees to become interested. With their deed completed, the bees will fly back over to the table, flying up to the guest first to pull their attention down to the table, where in thanks for all of their help, they will deposit some beeswax to seal the envelope off, which weighs it down just enough to send it flying down the ramp and into our mailbox. Which is revealed to have been a snail this entire time, explaining what the heck snail mail is. So one of the challenges of building a Rube Goldberg machine is that they are not typically designed to be run back to back very easily. And so to address this in terms of resetting the machine for a next guess or a next run through, and to address potential concerns around contamination due to COVID-19, we've minimized the number of touch points as much as possible. So in order to run the machine a second time, a guest needs to only push back the carriage return on the typewriter and set the weight back in place, all of which can be done from the starting location. And our playtesting showed that most, if not all, guests view the experience from this starting location. And then all of the virtual elements will reset themselves from this point. So another area of concern that the incorporation of AR brings to the table is the issue of field of view and guests losing track of the interaction as it plays out, and playtesting supported that conclusion. People are having a hard time keeping up with the speed of the interaction. So overall, we needed to slow down the tempo of all of our animations in order to help guests keep up with the experience. The other 2 points within the machine that we identified as being troublesome were the transition points from the table up to the bird cage and from the plant and flowers back to the table, as because these are not really playing out linearly the same as the rest of the machine. So what we did to address this was using spatial audio. We put a speaker inside of the bird cage to attract the guest's attention when the bird wakes up and starts to chirp. So that will immediately pull the guest's attention up to the bird cage where they need to look. And then we also used a guest device tracking, an API within Arena, to have the bees fly up to the guests, no matter where they're standing, fill their screen, and then fly down to the table, which will pull their attention downwards. And now I'll pass it over to Bella to talk about some of the changes we made after softs.
Thanks, Jack. So playtesting and feedback from soft opening led us to make changes to the layout of some interactions. The Ico bird, which originally has been inside of the cage, was not occluded by the cage itself. We had designed around this issue for later moments, so this was especially breaking guests' immersion. We addressed this by moving the bird to be asleep on top of the cage at the start of the interaction, getting woken up when the cage door opens. So this solution works neatly around this issue of occlusion through strategic placement of objects. Next, I will be talking about the art assets in our design. So we draw inspirations from these 3 different parts. On color palette, as also in our design. There are always animal elements in his cartoon and machine, as a fun part or a surprise element. Here in our design, the bee here will produce the wax and the bird will use an umbrella to fly. The second part is from the design pillars. So we want to create virtual assets that are hard to achieve in physical form or in real time. For example, we want to make a mess by dropping down the book from the bookshelf. It would be hard to clean up or reset if it is physical. We want to make the impossible possible, like speeding up time. We made the flowers blooming in a second. And we also want to create humors like Rube Goldberg did. The smell coming from inside of a mailbox and the balloon inflating and flies away the watering can. The last part is from the playtesting we had. Some feedback shows that users want a clear sign to show them where to start the whole chain reaction, and also the assets to show them the whole storyline. Overall, all of our assets followed the same vintage color palette and an old cartoon style. Next, I will pass it to Adeline to talk more about our animation.
Thanks, Bella. We have created animations based on our interaction designs in terms of bringing these fantastical elements to life. And we continue to use Babylon as our GLTF exporter and created these different GLTF assets with animations. There was much fun working with GLTF formats because it has brought us some unique challenges to solve for our 3D pipeline. The first challenge I want to share is the double-sided material that we have worked with. This issue comes with a watering can asset that we used in one of our interactions. A vanilla exploitation will not show the backside on the faces. And after doing some research, we found that we need to uncheck the backface calling options on the Babylon material node in the Maya material editor to enable the double-sided lighting for our GLTF assets. Another challenge we were facing is the animation exploitation using the Babylon GLTF exporter. We created balloon animations using Maya class simulation, and we created the flower blooming animation and letter sliding animation with Maya deformer animation. However, by default, the Babylon GLTF exporter does not support exporting those class simulations and deformer animations directly. So we found a way around this by converting those animations to blend shapes. Here we use the letter animation as an example. For this letter animation, we used the curve warp deform animation in Maya and then created blend shape targets frame by frame from that, so we can achieve a smoother animation for our GLTF letter assets. The last challenge we want to share comes along with the snail animation. Initially, we were using the ribbon rig solution to rig and animate a snail. However, we found that, again, the animation cannot be exported directly. So we rethought about the best solution for creating this imaginary animation by using blend shapes. We created rigs on those blend shape targets to help create a better result for the final blend shape animation. And finally, we completed snail animation based on our story and design. Next, I will hand it over to how to introduce the tech implementation in Arena.
Thanks, Edwin. For tech part, we use April tag for guests to scan and reset their location. Also, we're using April tag to map our virtual object to physical space, such as birds on the cage and branch flower on the branch. For our virtual part, we set a global counter and calculated each event trigger time point and use a counter to trigger animation and hover event. For animation, we create GLTF animation for complicated movement and use Arena built-in transform for simple movement. For hardware event, we upload our control code to Raspberry Pi and connect to Wi-Fi to control all the triggering of hardware. Next, we'll have Wizard to introduce the detail of hardware interaction.
Thanks, Hao. So using the Arena and controlling hardware by Raspberry Pi at the same time, we create a series of magic moments in the AR board machine. The start point of our machine is distance sensor in the birdcage. The distance sensor will detect whether the birdcage is pulled and open, and then turn on the fan and play the bird train sound from the speaker to guide the guest to look at the birdcage. At the same time, the Raspberry Pi will start the counter in the Arena to trigger the first animation of bird in the scene. After play a series of animation, when the bird falls down, animation is ending. The battle server will be triggered. The panel of battle will go down. The book will also rotate with the panel. The sound of writing the balloon will be played. To make it seem like the virtual book plays a physical battle to inflate the virtual balloon. After play the flower balloon animations, beans fly to the flower. We use the Arena API to detect position of the gas to guide the beans fly to the gas. The maximum number of beans will fly to different gas is 3. Finally, when the later slide into the mailbox, a server with the flag attached on the wood bar will be triggered to shake several times to create an impressive ending moment that's our main story, sooner or later in the snail box. When the machine delivered to a museum, it could be installed just in 6 steps. First, put the furniture according to the cat diagram indicating the relative distance between objects. The objects such as birdcage, ramp are fixed on the table. Also, the position of where put the books and typewriter or mark on the furniture. It's easier to set up all the physical objects on the correct position. Then, it set the alpha tag and the desk on the correct position, which is aligned with the bottom edge on the desk and the third battle on the desk. We attach the hardware components, IoT relay, extension code, and Raspberry Pi in the one board. It's easier to move them together or hide the wires. Also, we attach tag on the wires and each hardware to make it clear how to connect the fan and 2 servos, one on the battle and one on the mailbox with the Raspberry Pi. The next step is connecting the speaker and the distance sensor in the birdcage with Raspberry Pi. The final part is turning on extension code, which is connect with electricity. When the Raspberry Pi runs, after it connects with Wi-Fi, the machine setting is complete. Now, every time when turn on the extension code, the program called Arena API and country hardware will run automatically. We have robust testing that left the running program for 4 hours and start and reset the machine every about 15 and 20 minutes to simulate the installation in the museum. All the content such as installation details and frequently asked questions we document in the one file to ensure the museum could understand how to install them. Also, we provide the details of hardware and software. As for hardware, we aim to allow users to replace hardware by themselves if something is broken. So we provide the spec of each hardware and how to connect them. As for software, we introduce how to refine the precision of virtual objects in the Raspberry Pi. We have prepared and will deliver all the project to the museum next Monday. We appreciate a lot of people help us with our project in this semester, especially Arena and hardware controlling are all new for us. Thank you, and now open to questions.
All right, congratulations, team. Good job on your final presentation. So if anybody has any questions, they can put them in chat or raise their hands and Dave will help moderate. Thanks.
Go ahead, Jesse. So on installations, something always breaks. So what's going to break first?
Now, in our testing, we're just afraid about the distance sensor and the server. That because we're not sure it will run very stable or how long they were broken. But we provide another one distance sensor and another server to the museum. So if they are broken, they maybe can exchange them. And also we also provide a link where we buy this hardware. So if their backup if they have if they need another server or distance sensor, that they would also can buy them by themselves.
Okay, thanks.
Mike, you have a question? Yeah, I'm curious because a lot of 9 and 10-year-olds take bee buzzing and bees as sinister and might avoid, and a bee flying toward them, they might dodge and avoid. So I'm just curious if in your playtesting, the choice of bees coming from the flower straight toward you worked for kids.
So unfortunately, because of some of the restrictions around building access this semester, we haven't been able to test with 9 to 15-year-olds because they haven't been allowed in the space. But one of the things that we did to address this was, number one, we had some incredible help. We had some incredible work on the team in terms of making the bees, frankly, pretty cute. From some of the feedback we've heard with their lovely blushing cheeks. As well, the other thing is with the device detection, the bees will never move beyond a certain distance. They will just move, they will approach the guests, but not sort of fly at them in any way. So it would just come up to them to a certain point slowly and then move on. So between the combination of slow speed and then a relatively cute looking bee, we're hoping to avoid some of those issues.
Carl, you have a question?
Yeah, I like the sound that you put in the bird cage to help attract people there. And I know there's a lot of other sound effects. Did you consider putting actual local sound in other locations to help people track the action?
We had talked about doing sort of a stereo setup, but at that point it was between 2 servos and a speaker. It was starting to kind of stretch the limits of our Raspberry Pi setup, and so what we have now is a secondary speaker could replace the speaker that is currently in the bird cage. And so like a computer dual speaker setup could be spread out, but then you would sort of lose the placement in terms of like the audio coming from the left. So we wanted to just kind of have diversity in terms of what is guiding your attention. But yeah, that was something that we had discussed, but not gone into.
Thank you.
All right, that's time. Thank you, team. Good job on your final presentations. You can turn your mics and cameras off. We'll get you off the spotlight.
Thanks so much.
And if Chain Reaction can get ready to join the spotlight. Get you in there. And that's all of you, whenever you are ready.
Great. Can everyone hear me all right?
Yep.
Awesome. And you can see my screen just fine?
Yep.
Great. Cool. Everyone on the team good? Get a thumbs up. Awesome. Great. Well, good morning, everyone. Thanks so much for coming out to our final presentation. We are Chain Reaction, and this is our team, as well as our faculty advisors, Brenda and Dave, and our client, Raul from Games for Change. So this past semester, we've created a multiplayer point-and-click role-playing game about nuclear testing for the Games for Change Festival. So in our game, players talk to each other as well as fictional government officials over a video conference call, which makes up the multiplayer role-playing half of our game. They also learn more about the history of nuclear testing by examining and analyzing primary source materials in a point-and-click game that we developed in WebGL. So we've worked really hard on our experience this past semester, from researching the transformational content to designing an experience whose gameplay and interactivity would enable our intended audience transformations, and finally to honing and refining said experience through playtesting. These metrics ultimately describe where we've invested the bulk of our time as a team, as well as where we've grown most as ETC students. So with those metrics in mind, let's dive into the context behind our experience. So as I mentioned earlier, the game is intended to be played by attendees of the Games for Change workshop week for the festival, which is a 90-minute session from July 6 to 10. We therefore designed the game to be played over a video conference call, as well as accommodate upwards of 40+ players. So in addition to these logistical constraints, we designed our experience to transform our audience in 3 principal ways. First, we wanted our audience to walk away from our experience just knowing more about different perspectives on US testing. Second, we wanted our audience to recognize that their initial understanding was incomplete. And third, we wanted our guests to recognize the importance of these new perspectives that they were previously unaware of, or that were even antithetical to their previously held beliefs. So we were inspired by the experience discovering the barriers in our audience, as well as by the process the team went through in researching the subject. We as a team were transformed through the mere exposure to the primary source materials themselves. So with that in mind, I'll pass it off to Claire to talk more about design as well as narrative.
Thank you, Derek. So in our game, players play as the interns from 4 organizations as Department of Defense, Department of Energy, Centers for Disease Control, and a nonprofit organization, ICANN. These 4 organizations are testifying for the funds from the US Senate. And the whole game is played over 4 different phases: the introduction phase, the investigation phase, the discussion phase, and the voting phase. In order to overcome the barrier that Derek mentioned, as well as to give players the initiative to research the nuclear testing topic themselves, the team put efforts on delivering an engaging and interactive role-play experience so that the players can have an opportunity to view the nuclear testing topics through a lens that they don't usually have in normal lives. By being exposed to different stories and bias told and generated by different perspectives, we expect the players to come up with their own conclusions about what should be done about nuclear testing and have a better understanding and a view toward its historical background through thinking and a discussion. Next, I want to explain a little bit more about how we implement these 4 phases in terms of the game flow. So first, our players will join our games for Chain Festival through a hopping link sent to them in pre-registration. The team will meet the participants there in the hopping session to give them a better sense of the story as well as their role by acting. And once the players are receiving all the information of the story and the character setting, as well as the goal of the game, they will be given the link to our web game where the investigation happens. This is the moment when the players will be researching and learning more about nuclear testing, and eventually after 35 minutes of the investigation, they will be back to the main hopping session to exchange the information they found and vote for 2 organizations, ideally within the rest of the 30 minutes. Now that we have talked about the design, and next, let's unpack the narrative design with this video clip of what our players first see when they join this experience.
We have an expert witness testifying today. Dr. Charles Nolan was an MD. He rose to be the deputy head of the Nevada test site, and he worked there for the last 30 years of nuclear detonations before his retirement in 1992 when test detonations were stopped. His expert testimony today at the Senate Budgetary Committee will determine the outcome of the hearing. So your job as interns is to pay close attention to Dr. Nolan's testimony so that you don't miss anything.
Sorry I'm late, everyone. Unfortunately, today's hearing needs to be canceled. The Nuclear Testing Legacy Act will be taken off the agenda.
Excuse me? Canceled? Senator, may I ask why?
I just received word that Dr. Charles Nolan passed away last night. Well, he died peacefully in his sleep last night at the age of 92. Today's hearing was relying on his testimony, and this committee does not have time to find a new witness. I do not think we can go forward with the Nuclear Testing Legacy Act at this time.
So the doctor may be gone, but his work was his legacy. Suppose each organization here today put together testimony based on the documents he left behind.
Are you confident in your intern's expertise?
Well, of course, I
Major
think...
Chen, may I? Do you think you can bring the evidence you need to make your case by the end of tomorrow?
Yes, absolutely. I have the utmost confidence in the interns. We might not be lifelong experts, but we can certainly do our best. For all the departments, I believe that by constructing our testimonies with our interns, we'll receive input from a larger and even more diverse set of perspectives. It really could help you make a more informed decision, Senator.
Well, it would certainly help speed things up. Okay, the hearing is rescheduled. Take your interns into breakup sessions to work on your research. I want to see your very best work, both in the research and the testimony. Good luck, everyone. So as you saw in the video, we asked the players to only be responsible for the notes taken in the very beginning of the gameplay to try to eliminate the bias preset by the roles and the perspectives. Because of the scenario, the players are tasked by the representative of the departments to collect the evidence in Dr. Nolan's office and put together the testimony. After presenting all the testimonies and listening to the reasons from each organization of receiving the funds, the players are given the chance to vote for the 2 organizations that they believe can improve the nuclear testing situation to win the full funds from the senator. The result will be announced at the end of the gameplay as well. So now you know the story plays a big role in the whole gameplay, and the team also believes that the environment can tell the story. That's why we set the overall color tone as cold and desaturated to show the year of this office being abandoned since 1992. The messy layout of the room is also designed intentionally to show the Dr. Nolan's eccentric personality. Now I'm passing this to Oscar to talk about programming and implement.
Thank you, Claire. So next, I'll go over several technical details for our game. So first of all, I would like to talk about the main platform for our game, which is a web browser. We choose this because hopping the Game for Change conference platform is essentially a website. So by hosting our game online, our players do not have to install any extra softwares, and everything can be handled in one single browser. And connecting with our narrative design, players will be entering Dr. Nolan's abandoned office for investigation. So the main functionality of our game would be an interactable environment. And here's one example for the interaction. And in this room, players will move around and look for artifacts, which include text, images, and even audios. Some artifacts are hidden and not so easy to be found, and we'll use this to prompt discussions by encouraging players to share information about some hidden stuff they found. And other than pure information, to give players a better understanding of the departments they belong to, there will be a thought bubble next to every artifact, which is like a summary from a specific angle. And for the same artifact, the content of the thought bubble is different for different departments. And next, because we asked the players to choose 2 most important artifacts from what they found, we provide them with an inventory system in-game, which has the form of a notebook as a metaphor. And after the investigation phase, players will submit the 2 artifacts they choose. And these results will be collected in a spreadsheet in real time, so that we, as the host, can use this information for further discussions. And finally, for the voting phase, all players' decisions will be collected, and a graph will be generated automatically in real time for us to display the results. And that's it for the tech part. Next, we'll have Shiva to talk about the playtest we have so far.
Thanks, Oscar. So we ran 4 different playtests after halves over week 9, 11, 12, and 14. We were fortunate to get more than 30 different playtesters over these 4 playtests. The last 2 playtests particularly were crucial to understand the platform and also test our setup so we can handle our expectation of around 40 guests for our experience. So coming to challenges, designing for a group activity on a video conferencing platform was itself a big challenge. This challenge amplified especially when we moved from Zoom to Hopin, since each platform brings out the importance of a different kind of interaction. Constant story iterations were also difficult. We had to rely on our playtesting heavily to test our narrative theories, since the story was key to several aspects of the experience. Live events are impossible to predict, no matter how well they're designed for. Our design hinged on getting players to present conflicting testimony, and we had to provide a lot more information than originally intended to guide them towards conclusions that would disagree with each other and even with the players' deeply held beliefs. And technology in live events, particularly remote event with 40 plus people and 40 different devices, is also very unpredictable. Tackling our first challenge, one major change that we went through was to make the testimony session a much more involved interactive experience by including some of the interns to testify as part of the department, instead of just looking at talking heads and bosses, or talking heads of the bosses and senators. Other changes included onboarding and encouraging players to use the chat for better engagement. For story iterations, we went from a Mad Libs type form filling format for individual guests to a more collaborative discussion to fill the testimony with the boss. This helped a lot with everyone in the team understanding the story better and coming together to put forward a case for their department. Lastly, having 4 playtests also helped us be better prepared for the live event as a whole. We streamlined some processes with the stage manager in the background, having a one-way communication with all the actors to notify them about any change in plans in real time. We tested this with a Discord group call set up in our last playtest. We also learned that we needed a backup solution since our WebGL build was causing problems in some of our playtest setup. We optimized the scene as much as we could and also added a low-tech backup solution with Google Slides just in case anyone's WebGL build broke. Now I'll pass it over to Kat to talk about our next steps.
Thank you, Shiva. So I'll be talking about our next steps for delivering the project this summer and about the lessons we learned this semester. Our deliverable is a live experience that will be happening during the Games for Change workshop week as an interactive session. We'll also have a separate Games for Change festival session the following week. Much like today's presentation, we'll present our work from a design perspective and take questions. Our game includes the main room called the Senate floor and 4 breakout sessions for the individual organization teams to research and discuss. Myself, Derek, and Oscar are all acting as bosses of the 3-player teams, and Claire is acting as the senator. Shiva will be our stage manager, so having him as the boss of the last player team is impractical. This means we needed an external actor. So we've recruited ETC student Jack McLean to act with us as the boss of the 4th player organization. He's already been with us in 1 playtest and done a great job. To help us run the show and coordinate between our 4 actors and 1 stage manager, we created a cue sheet and script. We've also been in contact with the Games for Change collaborator who can help provide us with understudies in case of emergency. Over the course of the semester, we learned a lot of design lessons. First, we learned how important it was to divide our broad, complex topic among all of us. It actually led to our core game design that focuses on competing perspectives on nuclear testing. We also learned about the best practices for using subject matter experts. The SMEs we talked with were wonderful for specific questions and helping us know what questions to ask, but it was particularly valuable to stay in touch with them all semester. When we needed a playtester who could evaluate for historical accuracy, our SMEs were there. We learned that taking risks in a transformational design space can lead to great rewards. Our topic, genre, platform, and the large number of players are all inherently risky, but the risky choices tended to be the right ones. We believe that is because risks force us to think through implementation and testing in greater detail than more obvious choices. Finally, we learned about the flexibility needed to design for a live interactive event. It was crucial for us to have robust contingency plans every step of the way. In fact, just last week, we learned that our session will be taking place at workshop week instead of at the festival. And the flexibility we've had all semester has helped us handle the necessary changes smoothly. To go into more detail on the schedule, our event is in the middle of July, so we have about 2 months until the final deliverable. From graduation through June, we'll rehearse on our own and with Brenda to keep ourselves familiar with our script. In mid-June, after a contact from our client, we'll begin tech rehearsals. And finally, in July, we'll put on our show to the general public at the workshop week and deliver our retrospective presentation at the festival. We'd like to thank the many people who helped us throughout our semester, in particular our client Raul and our SMEs for connecting us with so much information on nuclear threat. And a huge thanks to our many playtesters, from the paper prototype to now. In conclusion, this past semester, Chain Reaction has created a multiplayer, point-and-click role-playing game about nuclear testing for the Games for Change Festival, and we are open to questions.
Great job, team. Congrats on your finals presentation. And so if there are any questions, you can put them in chat or raise your hand and Dave can help moderate. Thanks, everyone.
Go ahead, Jesse.
You mentioned there was a problem with WebGL on some of your tested browsers. Can you say more about that?
Yes. So first we chose WebGL as we mentioned because for the easier platform switch for the players, and WebGL is actually already like a pretty minimum requirement for the players. And still, even with that, there are some players with some pretty I would say like a low-end devices which either does not support WebGL or does not support the complicated scene that we have. So in that cases, our game may not work for them.
Okay, so mostly performance problems, but some incompatibility problems. Is that right?
Yes, exactly.
Okay, thank you.
I'll ask a question. I'm kind of curious, you talked about Hopin as a challenge. What were some of the surprises? And I guess especially contrasting Hopin to Zoom and how that sort of challenged your expectations of running a virtual event.
I can take this one. So Hopin is a video conferencing platform that runs in browser that is designed specifically for conferences. So there is a limit on the number of people who can share their video and audio at one time. You can see in one of these screenshots, it says the limit is 20. So one thing that meant is that we couldn't have all 40 of our players on screen at one time in our setup and ending scenes of the Senate floor. Another problem is that Hopin is primarily designed for speakers who are presenting slide decks or something like that, as well as roundtables where there's only one person asking a question at the time. So this meant that our playtesters were a lot less comfortable with unmuting, asking questions, and participating in the discussion than we wanted them to be. So the lessons that we've learned about how to create explicit moments for interactivity really helped our playtest improve between the two Hopin playtests. But we actually, as a result of the change in schedule to the workshop week, we're no longer married to Hopin as our choice of platform. but we still think that our experience creating more opportunities for interaction and creating explicit moments where that is what we're requesting of the players will be valuable regardless of which video conferencing software we'll be using.
Thanks.
And one more?
Go ahead, Raul.
Hi, folks. So this is Raul. I'm from Games Change. I'm the client. Thank you for this presentation. I just wanted to maybe hear a bit about the conversations that you've seen your players have towards the end, and whether or not you've had any surprising reactions in those conversations.
Totally, yeah. We were lucky to have about 30 playtesters, and we've collected some data on how much they already know about nuclear testing, which ranges from our SME, who literally wrote an entire thesis on this topic, to people who weren't even really aware that nuclear testing has stopped, that test detonations have stopped. So it has really been varied depending on their expertise with the information and with the perspectives that they come in. And we think that that's a good thing. We want them to wrestle with the knowledge that they have and gain more knowledge that they might not have thought that they could have. In terms of how the conversations have been going, we had a few difficulties with getting our playtesters to argue strongly for the priorities of an organization that doesn't match their own perspective. But with giving them more information on what that perspective actually is and making it more clear that the hosts, the actors as the bosses, were asking this of them, we were able to successfully get them to argue for organizations that actually work against their own personal priorities in real life. So that was a really big victory.
All right, thanks a lot, team. Great job with your final presentation. Congratulations. If you all can turn your mics and cameras off, I'll take you off the spotlight. And if exposé can get ready, I'll get you in the spotlight. All right, that's all of you. Whenever you're ready.
Thank you, Drew. Can everyone hear me all right?
Yes.
Yes. Awesome. Thank you. And can everyone see my slides?
Yep.
Good.
Thank you. Hello, and welcome to our final presentation. We are Team Exposé, and we built a game that tries to teach credibility checking to middle school students. Our project advisors are Shirley Saldamarco and Heather Kelly. Our client, Anahita Dalmia, is the CEO and co-founder of Ulteria Inc. They have created several narrative-based experiences that leave a lasting impact on their guests, and their latest endeavor is to create a website with games that will be centered on digital media literacy and disinformation. We will start off with a brief introduction of the project, our goals, and our approach. Then we will talk about our product, followed by our development process, and finally wrap it up with the next steps. Our client came to us with a goal to teach a topic of media literacy to middle school students. And they wanted it to be a standalone experience with a focus on narrative and engagement. So we picked credibility checking as our topic. Credibility checking is the process of establishing the reliability of online content. We adapted a popular worksheet called the CRAAP test as our source framework. The worksheet is a short list of questions that anyone can ask themselves to determine the level of reliability of online content. Our client also wanted us to build a game using Unity 3D that would run on web browsers on school-issued Chromebooks. This project would serve as a test for feasibility of using the engine for the development of their upcoming projects. Our project metrics are to satisfy client requirements, maintain the accuracy of transformational content, and incorporate gameplay and interactivity. I will now hand it off to Ray to talk about the product overview.
Thanks, Bhavin. This is the starting screen of our game. This screen is intended to give you a sense of the visual style of our game. And our story happens in a fictional high school. And also the name of our game is called the #Deep Fried. There are two core game components of our game. The first is the malware, which is a fictional social media app where the students in the school will post about their school lives and their school concerns, about their school policies, their emotional way. And also the second thing is the Melgo, which is a search engine that we build with the curated contents, with the prepared for the players to search. About our gameplay, there are 5 core modules. It starts with the school exploration, where the players can explore the hallway of the school and meet characters, and also see the reactions of clicking on different items. Then is the malware exploration, where the players will go to the social media and see the emotional contents posted by the students. Then they're going to do the article investigation to investigate if there are any credibility issues with the posted evident article by the students in malware. And then they need their own evident article to convince the students. Then they need to go to Melgo to search and pick the best reliable web page. Finally, they'll get feedback from these NPCs. And to better demonstrate the idea, I would like to show you a video demo. This is the hallway exploration module of the game, where players can click on items to see the reactions, to give them some context of the story. And they can also click on the conversations of the characters to see what they're saying. Now, they can also drag to explore more of the hallway and meet other characters, and once they speak to the major character, the progress moves on. Now, the second module, malware exploration. The players can see students are posting about their concerns of the school life here, emotionally. And players can also see students' comments under each post. Then the next module. The players now need to click into the link of the evident article in each student's post to see if there are any credibility issues with it. To fastly read through the articles, the players just need to click on the components of the article, and there will be a summary in the player's character's mind. And once the player clicks on a component that has a credibility issue, that issue will pop up in the character's mind with an explanation of it. This is expected to be the teaching part of the game. After clicking on all components, now the players need their own evident article, so they need to do the research in the Melgo by typing the hinted keywords. Among the search results, they need to pick the best reliable web page as their evidence to convince the students in malware. To investigate these web pages, they're doing the same as clicking on components and reading through the summary in the character's mind. The players can click on the share button on the top of the browser once they have made their choice. Then, the players go to the main character Alice again, and she will give the comments and feedback of the chosen web page. Also now in malware, there will be a reply post made with the chosen web page. And in its comments, the players can see the students' reactions to give them more feedback and the context. Thanks for watching, and now I'll pass it to Ching to talk about our art part.
Thanks, Ray. For the art part, based on the feedbacks from midterm reviews, we changed from the anime art style to the cartoon-like style, which is more attractive to our target audience and also easier for showing diversity. So following is our characters. We apply each character with 3 emotions for change with their different moods, and they all designed with specific color for connecting with their own dialogue frames. So the character could be easier to be recognized. Also, as we want to show diversity here, so we use character settings under different races for support the diversity. Another important part in our game is the in-game cell phone. That's the basic interface and the main screen of the phone. And they're applied with casting apps for adding more fun. And surely the main function is malware and malgo. For malware, this is a slice of malware's interface. We continue the appliance of our casting UIs and follow the basic user experience flow as most of other SNS platforms for getting audience the immersive experience. And for malware, we're showing some of our searching pages here. It also follows the basic design logic of searching engine user experience flow. For lower the confusion caused by the needs of crossing from different pages, we use minimum pages to improve the experience of searching. And this page is a short summary of some in-game UI assets. They're designed under the same logic for keeping united aesthetic, and some of them use some hand sketch elements for making the teenager audience feel more immersive. And next, I'm going to hand it to Shuxing.
Thank you, Chin. Let's talk about some of the tech parts we have developed. So to get started with, because the project was developed using Unity, we have to come up with our own dialogue system structure. The tech team designed this, and in the purpose to have the client to be easy to write in the dialogue, to adding new dialogue scripts, or for the client's tech team to adding new features. Let's take a look at the center highlighted example of Alice, said something something. As you can see, the dialogue script is mainly written in this format of somebody says something, and on the right of screen, you'll be seeing Alice in her sad face saying the exact same thing. The scenario manager has the purpose of parsing this dialogue script, and based on what you input in the dialogue script, it will lay out the scene for you and display all the text, or connects to other managers, or does flow control for you. On the other hand, you might remember the smartphone system from the previous slides. In the smartphone, you'll be equipped with multiple apps, and each app will have different app rules, just like their real-life counterpart. Let's take a look at the following example. At first, the user will click into the malware's homepage, and as you can see, there will be a lot of posts. And then you can click into one of each post to see their comments, and then click into the link and open up the web page in the browser. All these purposes can be done using clicks on the UI elements or clicking on the return button. So we designed this so that the client's tech team can only need to worry about the behaviors of clicking each UI clickable elements. There's some things we learned during the process. One is that the JSON format that we use to keep track of the malware posts and the format we use to keep track of the dialog script and the search index, they are in different syntaxes. And that leads to a management nightmare. That being said, you have to learn 3 different syntaxes in order to master the system. And that really, we didn't really see it coming. If we had time, we will probably switch to JSON for all 3 different structures so that there will be only one thing that you need to learn. Next up, let's have Aidan talk about some of the playtesting results.
Thank you, Shuxing. So in this semester, we have 3 live playtests with 2 local middle schools. We playtested with 20 students, and most of them are in 8th grade. And here shows how interested were the players in game. As you can see, the game is engaging for most of the players. They enjoy the process of investigate and validating the information, but we also had some feedbacks that they felt the dialogue in game was long and boring. And here's our transformational goal. This result is from our first playtest. 70% of the playtesters think the game changed their minds on social media posts after playing the game. And most of the playtesters confirmed that they learned something about credibility checking through the game. Next, I want to talk about the iterations we made based on the playtest. During our playtest, we found that even though we're using a smartphone system, which the middle schoolers should be familiar with, yet our playtesters still got stuck in the game and don't know what to do next. So we focused on these points and made the UI UX more user-friendly. And in our final build, the players can walk through the process smoothly. And here are some of the changes we made. Previously, we used highlighted keywords in a sentence to try to hint players, but players were not paying too much attention. So we made the hint into a more directly way and use a notebook image to clearly tell the players next steps. And we also find when players reading through the web articles, they had a hard time trying to find the share button because they need to scroll up to the very top to find it. So we made the header fixed and made new icon and animation for the share button to make it more noticeable. Finally, in the article investigation part, we require players to click all the components in the article to proceed, but we have no indicator to show which component has already been clicked, which makes the player struggling in figuring out the missing part. So we added the check markers and it worked really well. Another thing we learned from the playtest is our audience. We found that 6th graders and 8th graders have a difference in understanding the game content, even though they only have 2 years gap. Some 6th graders thought the game was about teaching them eating healthy, which is only the theme of the game, but not the inner core. But almost all the 8th graders can get the idea that the game is trying to teach them about credibility checking. Now I'll hand to Pawan to talk about the conclusion part.
Thank you, Aiden. Our major takeaways are threefold. As text is the primary medium of content delivery, we noticed reduced levels of engagement in our younger players, but an increased level of engagement in our older players who were more willing to read. In the future, understanding the reading capabilities of our audience in different age groups will be crucial. Secondly, our team struggled initially with refining the narrative structure of our game. We solved this by bringing on a trained writer on board to work with us. And finally, due to the broad nature of topics in media literacy, we as a team invested a considerable amount of time in narrowing down our teaching goal. However, with feedback from our client, faculty, and subject matter experts, we chose credibility checking as it is a concrete teaching goal that could also be completed within the course of the semester. And so we are wrapping up the project by handing it off to our client. We are doing this through a knowledge sharing session scheduled for 6:30 p.m. tonight. Our handoff package will consist of the Unity project, assets that we developed through the course of the project, design materials, and tech documentation on how to use these tools that we've developed. We would like to thank our playtesters, our subject matter experts, and our faculty and staff who gave us constant feedback. And also, most importantly, Anna Anderson, our writer, and Derek Chan for voicing our trailer. Thank you. We are now open to questions.
All right. Congratulations, team, on your final presentation. Good job. Any questions? Just put them in the chat or raise your hand and Dave can help moderate. Thanks, everyone.
Go ahead, Mo.
Yeah, can you tell us a little bit more about your target demographic? I thought the difference between 6th and 8th grade was interesting. I'm just kind of curious across those age groups, what kind of media do they normally engage in?
We tested with 6th, 7th, and 8th graders. We noticed that 8th graders were also slightly exposed to media more than 6th and 7th graders. And some of the 8th graders that we interacted with had also encountered media literacy as a topic in their school curriculum. And that also worked in our favor. And with 6th and 7th graders, they read very slowly and took a lot more time to process the information that we were showing on screen.
Sorry, a little more specifically, do they watch YouTube videos? Are they on social media at that age? Like, how do they interact with media outside of what you've created? What's my question?
Right. Oh, I can answer that. So 8th graders are more used to social media, using Twitter or we had initially sent out an audience survey to find out what their interests were in. Many of them responded that they used YouTube and social media like Twitter or Facebook, Twitter or Snapchat. And 6th or 7th graders, we don't have much data to actually tell whether they do explore these kind of media. So did that answer your question?
Yes, thank you. Perfect.
I've got a question. So you're going to be handing this off. Do you know how this might be used by your client in the future?
Of course. Our client is particularly interested in our tech framework, and they want to use the dialogue system that we have developed in some of their future projects. And they would also want to use this narrative structure that we have built and refine it further and incorporate it into some of their upcoming projects.
Thanks. Jesse, you have a question?
Yeah, you guys had mentioned that you were having a wall of text problem. When there was too much text, students would disengage. How could you do this project with less text?
I can answer that. Firstly, the dialogue. So we are a visual novel, so there definitely will be text in the game, and I think one way is to just to modify the dialogue, try to shorten the scripts. Also, we make the web page. The web page is actually very wordy, but we made a system that when you click on the certain component, there will be the protagonist thought that will be summarized the further component, and that will be like shortened version information for the player to get. Yeah.
Got it. Thanks.
All right, that's time.
Oh, sorry.
Congratulations to. Oh, go ahead, Mo. We have a little bit of time. Go for it.
Real quick question: how many characters were there total that you had to make for the experience? I saw maybe 4 or so in the slides, but were there more than that?
Actually, we use 3 of them. There's one as a backup character. So because of the character, because of the chapter limits, so we can only introduce 3 characters into it.
Okay, thank you.
And to add to that, our player character is never actually shown as a character in the game to increase relatability. And yeah, so that's 3 characters in our.
All right. Thanks a lot, team. Good job. Congratulations on your final presentation. If you could turn your mics and cameras off, we'll get you out of the spotlight. And if who's next? Blindspot. Blindspot, if you're ready to be spotlit, get your cameras and mics on, and I will find you.
All right. Can everyone see the slides?
Yeah, wait, one more and you're ready to go. I can see your slides. Who am I missing? There he is. All right, that's everyone, whenever you're ready.
Okay, yeah. So you can also hear me.
Yes.
Okay. All right, let's get started. Good morning, everyone. We're Team Blindspot. Welcome to our final presentation. This is our team. Our instructors are Mike and Shirley. The client of the project is Data Driven Diversity Lab. For this project, D3 is looking for an interactive transformational game targeting marginalized students populations at CNU. They want the game to address topics like bias, microaggressions, or stereotype threats. After brainstorming and discussing with the client, we agreed to make an experience that unfolds a story where a Chinese girl who just arrived CMU and experiences microaggressions in her college life. The transformational goals are first to raise awareness, and second to learn how to deal with these issues.
Our deliverable is a desktop 2D web-based game made by Unity. We deliver a final build along with source code and documentation that help the client make use of the game. For example, in-game, we have a larger system to track player preference, so we have a document to explain how to use that. The client will use the game in a larger context. The potential usage would be in workshops, dorm activities, orientations, and educational activities that brings up discussion. As for the metrics of success, first is transformational content accuracy. Second is client requirement, and finally, gameplay and interactivity. All right, it's now time to show you the edit demo of our game. The experience starts off with a prologue that sets up the context. Then it follows 3 chapters that each introduce several different microaggression scenarios. The player choices trigger different story branches and lead to different puzzle difficulty.
All my efforts could be seen.
Each chapter ends with a flashback that reminisces about her experience. Chapter 2 tells a story about Mei Mei feels excluded in an unfamiliar conversation. She overcomes by recalling her happy memory with her family and sharing her own culture with others.
Here, to break down the barriers between people, because every culture is worth being treated equally.
Chapter 3 happens at a home party where Mei Mei doesn't get to be invited to sing karaoke because others assume she's shy and quiet. Mei Mei gets help from her friend and confronts her feelings.
I always seek support from my loved ones when I feel depressed. I was a passenger traveling through the vibrant space to look for the dream destination. Still I am, and
this is a typical 30-minute experience. We have to collapse it into short video. We'll cover each chapter in more details in the next couple of slides. So we showed chapter 1 in our half presentation, but to recap, chapter 1 addressed the microaggressions called ascription of intelligence. Her classmate has a racial stereotype that Mei Mei is good at math because she's the nation, but such stereotype devalues Mei Mei's hard work. The puzzles are designed to experience the negative feelings of Mei Mei. During these chapters, players can either choose to confront the issue head-on or apply techniques such as use humor or express disagreement by selecting different choices. I'll hand it to Yuanqing to talk more about chapter 2.
Thanks, Shirley. The second chapter is about is regarding international value and need. Based on our research, it's very challenging for most international students to engage in US culture during their first year of study. It's not merely because the international students are not very familiar with American culture, but also due to the unawareness from native students. That's why we set up the scenario as having lunch at in-campus cafe during the Super Bowl time. To better visualize this topic, we designed some mini games to abstract what happens inside Mei Mei's state of mind. For example, when other people are talking about Super Bowl, Mei Mei will feel isolated because she knows nothing about that. Then the puzzle will show up, which is a jigsaw puzzle, simulates the process when Mei Mei is trying to understand what others are talking about. We can easily see there is a giant crystal ball from Mei Mei's mind. That means Mei Mei misunderstood what Super Bowl is actually meaning. After that, the second part of this chapter is basically a role reversal. Mei Mei is gonna talk about the Lunar New Year, which is a parallel festival of Super Bowl, but especially for Asian people. Here is the second puzzle in chapter 2, which is a picture matching game with switch interaction. We designed 2 versions of the puzzle. One is when Mei Mei recalls her happy festival memory with her family. So each of those 3 formed pictures represent a traditional activity Mei Mei had during the Spring Festival. The other one is about Mei Mei's perspective memory related to the microaggression she just had before. And just like we mentioned, the triggered version of puzzle in the experience is determined by players' response in the story. In the end, we designed a simple interaction to emphasize the importance of sharing. Players need to drag the dumpling into target position, just like sharing food with others. It implies the cultural exchange, leading to a better understanding between cultures on both sides. For the flashback, we continued our art style in chapter 1, which is abstract and clean. We used some animation to convey the feeling of being isolated. Like in this frame, we showed Mei's exclusion from the crowd by tearing up a piece of paper. And we also use distinct color to highlight the features we would like to express. For example, in this frame, we use bright yellow as the background for Mei and the sunflower, which indicates that Mei's state of mind is growing stronger and stronger. Next, I will hand it to Jamie to talk about our next chapter.
Thank you, Yuanqing. Chapter 3 focuses on the random invisible. Asian people are often labeled as shy and quiet, which leads to being ignored during the campus life, especially in the party. So the scenario of chapter 3 is happened in a home party, which begins with Mei arrives at the party and tries to hang out with others by sharing her thoughts during conversations and sing karaoke. So however, some people in the party feel surprised that Mei would like to join the party and forget to give her a hearty welcome. We designed a puzzle to manifest Mei's isolation in the party. So in this puzzle, the shadow Mei walks from herself towards the crowd first, which shows Mei's willing to integrate into the party. And the player needs to click on the side where the shadow is facing until Mei herself coincides with it. When Mei stands beside the crowd, they will gradually fade away, which shows people's ignorance to Mei caused by microaggressions. After this puzzle, we bring a new character, Grace, into the story, who is a close friend of Mei. More importantly, she is an Asian American who shares the same culture with Mei and can comfort her during the upcoming conversation. Like previous chapters, the following puzzle has two versions, triggered when Mei starts to talk with Grace. If player chooses to let Mei talk about some common topics to shift attention, the white version will be triggered. As the pessimistic memory about her isolation in the party being wiped out, her warm memory about with Grace shows up, but you can still see there's still some remains of previous pessimistic one. The other version will be triggered if player chooses to let Mei talk about the microaggressions she has just experienced. We use click interaction to break the pieces and finally dissolve them out. Compared with the previous version, the pessimistic memory can be destroyed completely, which implies that seeking support from loved ones directly is a better way to address microaggressions. For the flashback, we use some metaphors to express inner emotions. For example, in the left picture, we drew some labels stuck to Mei, which represent other stereotypes lying on her. And on the right, we used holding a hand gently to imply the strong support that a close friend can give. After the flashback, an overall ending immediately follows. As shown in the pictures, we referenced the sculpture Walking to the Sky in CMU, which signifies that Mei will insist on staying true to herself and tackling with microaggressions. So next, I'll hand over to Haiyun to talk about our playtest result.
Thanks, Jamie. So we have conducted 4 playtests through this semester. And after we finished developing all the chapters, we soon started our final playtest with different groups to see if they can relate to Mei's experience. And we have 7 international students from the final playtest. Most of the playtesters are of the same range as ourselves. We asked a lot of questions about the puzzles and the interaction. When asked about how engaging the puzzles are, most of answers are around 4 to 5, which means pretty engaging. And we asked about how difficult the puzzles are. The average is around 3, which means medium difficulty. And we wanna check how the players see the overall experience. And most our playtesters find the scenario pretty realistic. As for the ending of the story, most answers are around 4, which means our playtesters rate this ending pretty hopeful. As for the iteration, one is about color adjustment. We had several color adjustments when we found it's not right. For instance, in the puzzle tool in chapter 2, our mechanism is to swap 2 pieces at one time until you make up 3 complete images. Our design is to only make the top right piece in each picture colored and leave the other 3 gray until the whole image is cracked. So the left picture is our first version. According to the feedback, the whole image is kind of gray, so it's hard to notice top right piece is colored, which means it's not movable. So we added a yellow and blue background and added colors to Mei on the right to make the piece more noticeable. We also added a lot of visual hints instead of text to make the experience both fluent and intuitive. Like puzzle tool in chapter 2 in the left, as we just mentioned, just color is not good enough to indicate the top right piece is not movable. So we added a pin to each picture to emphasize that later, and that's more intuitive. We also adjusted the design of puzzle all the time. For example, Mei asks about Super Bowl, which she is not familiar with. Our client mentioned her vision of the trophy could be a crystal ball instead of a real trophy, which would be logical just going on the name of the game. And she might not be aware of a detail like the 50-yard line. So we replaced the real trophy with a crystal ball, and that works better. Next, I will hand it to Michael to talk about the tools for future usage.
Yeah, thank you, Haiyun. So to assist our client for future usage of this project, we implemented several tools. In order to get more straightforward data, we added a logger system to track player behavior throughout the gameplay. Each data point is sent directly to the Google form, and this figure shows the preference of a certain question in our game. We also track players' total playtime spent on each puzzle. This helps us tune in the difficulty levels and allowing us to see if our visual hints added are working or not. For flexibility in future usage, we separated the dialog system from our build to allow clients to edit the script directly without rebuilding the game, since they are loaded through runtime. Here's an example of the code block representing a line in our game. Besides, we also make the multi-choice questions editable outside the build, so that client can create their own branches that lead to different endings. Here's an example of the code block representing a multiple choice question in our game. And now let's take some time to see how client comments on our project.
This has been a fantastic experience for us as clients from start to finish. Team Blindspot were eager to ground their design in theory and research from social psychology on implicit bias, and they've created a game in which they depict the experiences of international students with great care, authenticity, and empathy. In addition, on a personal note, working with Team Blindspot has been a real pleasure. Getting to know them and work with them every week, I was continually impressed by the level of creativity and artistry and beauty that they've infused in their game. And now as we wrap up the semester and celebrate the team's accomplishments, the role of D3 will shift from client to researcher. We intend to run a number of evaluation studies measuring the game's impact on players starting this summer. And looking ahead, we will also be designing and implementing a number of outreach efforts, including workshops that use the game as a center point and indeed a starting point to have deep conversations about implicit bias, identity, and microaggressions, both at CMU as well as K-12 schools outside of the CMU campus.
Yeah. So through the playtest and iteration that we did this semester, here are some main takeaways that we learned along the way. First, to build authentic experiences, it is helpful to refer to both research that has been done and our own experiences. Second, for our in-game puzzles, it's important to balance the difficulty and intuitiveness so that players can always stay in the flow. Third, it is always a good approach to rely on clients, especially when they are professionals in the field that we are exploring. We'd also like to use this time to thank all the people who have helped us during this semester. And to recap, we are Team Blindspot. We designed a transformational experience that aims to raise awareness and call to actions on microaggressions towards Chinese international students. And we are now open for questions.
All right, congratulations team. Good job on your final presentation. Any questions? Everybody can just throw them in the chat or raise your hands and Dave can help moderate. Thanks everyone.
Go ahead, Bob.
Hey, so recently there was the anti-Asian crimes happening after COVID. Did that in any way modify your design, or it caused you maybe to include those kind of actions into the gameplay?
Yeah, like because we like to because we discuss this topic in chapter 2. Like we would like to deal with the cultural changes, cultural difference between the different cultures. So we definitely like relate to this event happened recently. Like because we would like to all want to do like we need to like make efforts to like break the ice between the different cultures, like the stereotype or microaggressions between each other. So we would like to like talk about this, involve this and into our chapter 2 design. Yeah. So that we choose the cultural difference, the cultural difference in chapter 2.
Okay, thank you.
Did you all see Bob's question in the chat? Go for it, Bob.
Yeah, so I know that you're trying to maybe spread a bit of awareness to microaggressions, but what's the proposed solution? Is that, if someone does a microaggression, do I point it out, or do we step back and not talk about it based on the research or what you've seen?
Yes. So before I answer that question, so I just want to like point out that in the current circumstances, it's not that possible to like completely erase microaggressions, right? So it is always be there. And so for us, the solution is to targeting on both non-marginalized group and also marginalized group. And for the non-marginalized group, it's more important to raise awareness. And for example, I want the players who play this game to know that, even for everyday conversation, it's possible to hurt someone in those scenarios. So they will be paying more attention to those situations. And for marginalized students, like international students in our game, and we want them to apply some of the techniques we embed in our game, for example, to like respond to those situations more actively by and also like seek help from their loved ones, talk with your friend and family and confront your feelings, and also maybe applying techniques called like sharing, and you can share your own culture or memory to others. Okay. And yeah, we hope them like do something like this.
Okay, but so basically when you have a microaggression, is it recommended that you point out the microaggression there, or just find support and move on with your life?
I think it's depend on the situation, and sometimes for people it's better to like just do directly pointing out there, and for some people actually it's better to solve it more in indirect way, but both of them are actually good strategies.
Oh, okay, all right, thank you.
All right, team, that's time. Thanks so much for your final presentation. Great job. Great job to all the teams who went today. 3 days of finals down. We have one more tomorrow morning. So everybody else, I hope you have a good rest of your day. Take care, and faculty will